Today we'll discuss analysis of frame with sway by Kani's method when both horizontal and vertical load is acting. So this is the question. Analyze a two-story frame subjected to horizontal and vertical loading. The details of the frame and loading is given below. So here this is a two-storied frame, and here this is the horizontal loading, 8 kilonewton acting at joint 3 and 16 kilonewton acting at joint 2. And the horizontal load you are having on the horizontal span or member A3-4, that is 12 kilonewton by meter. Then on the horizontal member 2-5, there is having one eccentrical loading 24 kilonewton at a distance 1 meter from joint 2 and 3 meter from joint 5. And this is the horizontal span length is 4 meter, and the first story height 4 meter and second story height 4 meter. And the moment of inertia you are given for 1, 2 and for 5, 6 I, and for 2, 3 and 4, 5 I, and for 3, 4 and 2, 5 this is 2I. So here this is the frame, two-storied frame. Here the sway of the frame takes place due to both vertical and horizontal loading. What is the first step? So what we'll find out first, that is your fixed end moments. So here you see, find out fixed end moment MF12, MF21, MF23, MF32, then MF34, 43, 45, 54, 56, 65, then MF25 and MF52. But here you see in vertical member, there is no loading. There is no loading just between 1 and 2. So what is the fixed end moment at the end 1 and 2? MF12 and MF21 is equal to 0. Because here there is no loading between 1 and 2 vertical member. So MF12 and MF21 is your 0. Similarly, MF23 and MF32 is also 0 because between 2 and 3 there is no loading. Then similarly between 4 and 5 there is no loading. So MF45 and MF54 is also 0. And between 5 and 6 there is no loading. MF56 and MF65 is equal to 0. Then so find out what is the fixed end moment due to the vertical loading. Here you see 3, 4. So there is your acting the UDL 12 kilonewton by meter. So what is the moment, fixed end moment here? MF34. So this is equal to minus 12 into 4 square by 12. WL square by 12. So this is equal to minus 16 kilonewton meter. Similarly, what is MF43? So plus 12 into 4 square by 12. So this is plus 16 kilonewton meter. Then due to this eccentrical loading, what is the moment here? MF25 and MF52. So here you see, so due to eccentrical loading, you know what is the formula? How to find out the fixed end moment here? This is equal to minus W A B square by L square. A is equal to 1 and B is equal to 3 and L is equal to 4 and W is equal to 24. So minus 24 into 1 into 3 square by 4 square. 24, 1 into 3 square by 4 square. So this is equal to minus 13.50 kilonewton meter. Similarly, MF52 plus W A square B by L square plus 24 into 1 square into 3 by 4 square. 1 square into 3 by 4 square. This is plus 4.50 kilonewton meter. And the other, this vertical member, the fixed end moment is 0. In this vertical member, the fixed end moment is 0. These are the fixed end moment. What is the next step? What is your next step? So you have to find out the fixed end moment of joint 2. What is the fixed end moment of joint 2 and joint 5 and joint 4 and joint 3? So you know what is the fixed end moment of joint 2. So MF2 is equal to MF21 plus MF25 plus MF23. Similarly, here also MF52 is equal to MF56 MF5 is equal to MF56, MF52, and MF54. Similarly, at joint 4, how many members meet? 2 members, 4, 3, and 4, 5. So what is the frictional moment of joint 4? MF4 is equal to MF43 and MF45. Similarly, at joint 3, what is the frictional moment? MF3 is equal to MF34 plus MF32. In this process, find out what is the frictional moment of joint 2, 3, 4, and 5. So this is frictional moment of joint 2, 3, and 4, and 5. So this is the moment. At joint 2, minus 13.50 kilonewton meter, joint 3, minus 16 kilonewton meter, joint 4, plus 16 kilonewton meter, and joint 5, plus 4.5 kilonewton meter. So after getting the frictional moment of joints, then what you have to do here? Because here there you are having the horizontal loading at the joint 2 and 3. So here having 8 kilonewton at the joint 2, and at the joint 3 having 8 kilonewton, and at joint 2 is 16 kilonewton. So find out what is the moment due to horizontal loading. So find out MRF is equal to, first you find out for story 2 what is the story moment, then find out for story 1 what is the story moment. Because due to this horizontal loading, you have to find out what is the story moment for story 2, and due to this loading, what is the story moment for story 1. So when we are considering the story 2, you have to take only this loading, only up to loading which is acting at the joint 3, 8 kilonewton. When you will find out the story moment of story 1, you have to consider this load and this load, 16 plus 8. So this is equal to 24 kilonewton. So first to find out what is the story moment for story 2. So what is the formula? So this is the formula. MRF is equal to QR HR by 3. So already we have discussed in previous class. So story moment is equal to QR HR by 3. But for story 2, so you have to take the Q2 is your 8 kilonewton. What is the load you are acting at the joint 3? You have to take, this is your Q2, 8 kilonewton. And M2F, the story moment for second story is equal to M2F is equal to Q2 H2 by 3. 8 into 4 by 3. H2 is the height of the second story. Height of second story is your 4 meter, and height of first story is also 4 meter. So this is equal to 8 into 4 by 3. So this is equal to 10.67 kilonewton meter. So this is the story moment for story 2. Similarly, find out the story moment for story 1. So here you have to take the load. Q1 is equal to 8 plus 16. What is the load you are acting here and here? So these two you have to consider when you are considering, when you will find out the story moment for story 2. So Q1 is equal to 8 plus 16. Q1 is equal to 8 plus 16. This is equal to 24 kilonewton. So M1F is equal to Q1 H1 by 3. So Q1 is 24, and the height of the first story is equal to 4. So 24 into 4 by 3. This is equal to 32 kilonewton meter. So always you see the story moments are recorded in small rectangular blocks at the mid height of each story to the left of the first column line. You have to remember this one, the story moment where you have to represent. So in this way you will find out the story moments. Then you have to find out the rotation factors. Here you see, so here this is your joint 2, joint 3, joint 4, joint 5. For joint, so you will find out what is the rotation factor. You will find out what is the rotation factor for 2, 1, 2, 5, 2, 3. Similarly 5, 2, 5, 6, 5, 4. And similarly at joint 4, 4, 5 and 4, 3. And at joint 3, 3, 4, 3, 2. You have to find out the rotation factor. So for rotation factor, what you have to first find out? You have to find out the relative stiffness of the member. Then you have to find out the relative stiffness of the joint. Then you can find out what is the rotation factor using the formula. Already you know. So this is the first column is your joint 2, second members, third is your relative stiffness, fourth is the relative stiffness, sum of the relative stiffness, and the fourth column is your the rotation factor. So here how many joints? Already we have discussed 4 joints, 2, 3, 4, 5. So at the joint 2, how many members meet? 2, 1, 2, 3, 2, 5. And at joint 3, how many members meet? 3, 2, 3, 4. Joint 4, 2 members meet. 4, 3, 4, 5. And joint 5, 3 members meet. 5, 6, 5, 4, 5, 2. So these are the members right in the second column. Then find out what is the relative stiffness of the member. For 2, 1, you know what is the moment of inertia. So how to find out the relative stiffness of the member, you know. So this is the moment of inertia of the member divided by the length of the member. So here you see the moment of inertia for each member you are given in the question. So for 2, 1 or 1, 2, the moment of inertia is I and the length is your 4. So the relative stiffness is equal to I by 4. Similarly for all members, the moment of inertia you are given and the length also you know. So you can find out easily what is the relative stiffness of the member. So for 2, 1, I by 4, 2, 3, I by 4, 2, 5, I by 2, 3, 2, I by 4, 3, 4, I by 2, 4, 3, I by 2, 4, 5, I by 4, 5, 6, I by 4, 5, 4, I by 4, and 5, 2, I by 2. Then find out what is the relative stiffness of the joint 2. So what you have to do? How many members meet? 3 members. So K2 is equal to K21 plus K23 plus K25. So K2 is equal to I by 4 plus I by 4 plus I by 2. I by 4, I by 4, I by 2. So this is equal to I. So the relative stiffness of the joint 2 is equal to I. Similar way, find out what is the relative stiffness of the joint 3. K3 is equal to K32 plus K34 is equal to I by 4 plus I by 2 is equal to 3I by 4. Then K4 is equal to K43 plus K45. Here is equal to I by 4 plus I by 2 is equal to 3I by 4. Similarly, K5 is equal to K56 plus K54 plus K52 is equal to I by 4 plus I by 4 plus I by 2 is equal to I. So this is the relative stiffness of the joint 2, 3, 4, and 5. Then after getting this relative stiffness of the joint, then easily you can find out what is the rotation factor using this formula. You know the rotation factor, how to find out. Rotation factor is equal to minus of the relative stiffness of the member divided by the relative stiffness of the joint. So here for 2, 1, when we find out U21, the rotation factor for 2, 1, U21 is equal to minus of K21 divided by summation of K. So K21 is equal to I minus half into I by 4 divided by I. So this is equal to minus 1 by 8. Similar way, you can find out what is the rotation factor for 2, 3 minus 1 by 8, 2, 5 minus 1 by 4, 3, 2, U3, 2 minus 1 by 6, U3, 4 minus 1 by 3, U4, 3 minus 1 by 3, U4, 5 minus 1 by 6, U5, 6 minus 1 by 8, U5, 4 minus 1 by 8, and U5, 2 minus 1 by 4. So these are the rotation factors. Then what is the next step? You have to find out the translation factors or displacement factors. So these translation factors or displacement factor that you have to find out for the vertical members for first story and second story. So here you are having 2 story. In this tabular form, you find out translation factors. The first column is your indicate the story, and second column is your indicate the vertical members in each story. In each story, how many vertical members is your present. Then the third column is your relative stiffness of the vertical members. You have to write the relative stiffness of the vertical members. Then the fourth column, sum of the relative stiffness of all the vertical members in each story. So in first story, how many column is your present? Then you know what is the relative stiffness of the each vertical member of first story. Then the sum of this one is equal to this one. Sum of the relative stiffness of all the vertical members in each story. In first story, this is the sum of the relative stiffness, and in second story, this is the sum of the relative stiffness. Because at first story, the vertical members you are having 1, 2, and 6, 5. This is 1, 2, and 6, 5. First story, 2 vertical 1, 2, and 6, 5, and second story 2, 3, and phi 4. And you can find out first the relative stiffness of the member. Already you know this is the relative stiffness. Then you have to find out the sum of the relative stiffness of the all vertical members in each story. For first story, this is your I by 2, and sum of the relative stiffness of the second story, this is also I by 2. Sum of these two. Then after getting this one, then you can find out the translation or displacement factors. This you can find out minus 3 by 2, the relative stiffness of the vertical member divided by the sum of the relative stiffness of all vertical members in that story. So here you see. So when we find out that new 1, 2 is equal to minus 3 by 2 into I by 4 divided by I by 2. So the value is your minus 3 by 4. Similarly, new 6, 5 is equal to minus 3 by 2 into I by 4 divided by I by 2 is equal to minus 3 by 4. Similarly, for 2, 3, new 2, 3 is equal to minus 3 by 2 into I by 4 divided by I by 2 is equal to minus 3 by 4. Similarly, for 5, 4 also, the value is minus 3 by 4. This way you can find out what is the translation factors or displacement factors of the vertical members in each story. Then the next step, these are the formula you have to use. After this, you have to find out what is the rotation moments. Then you have to find out what is the translation moments. Then you have to find out the final moments. So these are the formula you have to use. Or when you find out the rotation moments, m dash 1 2 is equal to u1 2 into m1f plus summation of m dash 2 1 plus summation of m double dash 1 2. This is your subscript. M double dash 1 2. This is your subscript. Then m dash 2 1 is equal to u2 1 into m2f plus summation of m dash 1 2 plus summation of m double dash 2 1. This is your translation moment. This is your rotation moment. This is your far end rotation moment, and this is the near end rotation moment. You have to find out the near end rotation moment. So you have to take the sum of the far end rotation moment and the sum of the translation moment of the vertical members which meet at that joint. Then the rotation factor is your u12 is equal to u21 is equal to minus of k by summation of k. This is the formula you know. This is already. So translation moment also you can find out. M double dash 1 2 is equal to new MRF. This is the story moment plus summation of M double dash 1 2 plus M double dash 2 1. So when we'll find out the translation moment, you have to use this formula, translation factor and the story moment plus show the sum of the rotation moment of the top end and bottom end, top end, sum of the rotation moment of the top end and sum of the rotation moment of the bottom end. And this is the translation factor and this is the story moment formula. And the final moment that you will find out, M12 is equal to MF12 plus 2 M dash 12 plus M dash 21 plus M double dash 12. This is the fixed end moment at the end of the member. This is the twice near end rotation moment you know already. And this is the once the far end rotation moment. And this is the translation moment. But this moment you have to consider only for the vertical member. This is vertical member. But for horizontal member, you have to take only up to this one. Up to rotation moment. For horizontal member, when you find out the final moment, you have to take up to this one. And this is your not applicable for a horizontal member. When you will find out the final moment. So these are the formula you have to use for getting the rotation moment and translation moments. Then coming to the find out what is the rotation moment first and go to the joint 2. Joint 2. So the rotation moments you see when you will find out the rotation moment in first cycle you have to assume the rotation moments and translation moments are initially assumed to be 0. Initially the rotation moment and translation moment is 0 because you don't know. The translation moments of the vertical member and also the far end rotation moment. You don't know. So, but you have to find out the near end rotation moment. So, in first cycle, you have to assume. So, this is equal to 0. First, you start from the joint 2. So, you know what is the sum of joint moments at 2 minus 13.50 already you know. MF2 already we have calculated. This is your MF2, M2F is equal to, this is minus 13.50 kilonewton meter. Then M3F is also minus 16, M4F plus. So all fixed moment of the joint already you know, minus 13.50 kilonewton. So this is sum of joint of moment at 2 you have to take. Then sum of rotational moment at 1 is your 0 due to friction, and sum of rotational moment at 3 is your 0. This is you have to assume, and sum of rotational moment at and 5 is also 0. You have to assume. Then sum of translational moment of column 2 1 below 0 you have to assume, and sum of translational moment of column 2 3 above, this is your 0. You have to assume this one. So this you have to assume. Just to see in this figure. So when we find out the rotational moment here, M-21 and M-25 and M-23, you have to find out these 3 rotational moments. So what is the formula says? When we find out the rotational moment of this one, M-21, what is the formula? U21 into the sum of the far end rotation moment, So you have to take the far end rotation moment of this one and this one and this one. But here you see, this is your already fixed. So the far end rotation moment is your 0 here. But this side you don't know what is the rotation moment, and this side also you don't know what is the rotation moment. So here this is your assume. The far end rotation moment of 5 you have to assume 0, and the far end rotation moment of this one is also you have to assume 0. And also you see at the joint 2 how many vertical members meet? 2, 2, 3 and 2, 1. 2 vertical members meet. So you have to take the sum of the translational moment of the vertical members which meet at joint 2. So 2 1 and 2 3, 2 vertical members meet. So you have to assume what is the translation moment of vertical member 2 1 below this joint. This is above this joint. This is also the translation moment of the vertical member 2 3 is also assume 0, and the vertical members the translation moments of vertical members 2 1 is also you have to assume 0. So you have to assume this is 0, and this is you have to assume 0. This is also assume 0, and the translation moment of 2 1 vertical member and 2 3 vertical member also you have to assume 0. For first cycle joint 2, you have to take this is the rotation and translation moment, and you have to find out using this formula. Rotational moment M-21 is equal to U21 M2F plus summation of M-12 plus summation of M-21. So here U21 you know already we have calculated the rotation factor U21 minus 1 by 8, and the M2F is you know this is M2F minus 13.50, and these all are 0. So this is equal to plus 1.69 kilonewton meter. Similarly, find out M-23, then find out M-25. M-23 is also minus 1 by 8, minus 13.50, and these all are 0, plus 1.69. Then also find out M-25, minus 1 by 4, because the rotation factor of 25 is 0, minus 1 by 4. 25 is 0, minus 1 by 4, rotation factor. And the minus 13.50 plus 0, 0, 0, 0. So this is equal to plus 3.38 kilonewton meter. Here you got at the joint 2. So what is the near end rotation moment you got here? This one M-21, M-23 and M-25. 1.69, 1.69 and 3.38. So just to put in the tabular form here, at the joint 2, here you got M-21 got 1.69, and M-23 also got 1.69. Here you put when you are taking this joint 2, so the near end rotation moment here and this side, and for the horizontal you have to put here. So 1.69 you got, and here also you got 1.69, and here also you got 3.38. So you put this M-1 and M-25 and M-23. then you go to joint 5. This is the joint 5. So first you start here, then you go to joint 5, then you go to joint 4, then you go to joint 3. After getting all the near and rotational moment, then you have to go to the story 1 and story 2 and story 1. So you find out the translation moment. First you find out in the first cycle, first you find out the rotational moment in cyclic manner, then you find out the story moment of the second story, then first story. So the first cycle is complete. Then again you start the second cycle, again you start from the joint 2, the near and rotational moment, then again you find out the near and rotational moment at joint 5, then you find out at joint 4, then you find out joint 3 in second cycle. Then after getting the near and rotational moment in second cycle at joint 2, 5, 4, 3, then again you find out the translational moment in the second story and in first story. Second cycle is over. So similar way you have to find out the rotational moment and the translational moment. So you see here. So here you have to put these are the translational moment. So the translational moment always you have to put just inner side of the column, just midpoint. Inner side of the column at the midpoint. So for this vertical member, you have to put the translation moment here, and for this vertical member, you have to put the translation moment here, and for this vertical member, you have to put the translation moment here. For this vertical member, you have to put the translation moment here, and the story moment you have to put here. This is the story moment. So for second story, you have to put here 10.67, and the for first story, you have to put the story moment here 32, and the translation factor. You know the translation factor. So the for second story, you have to put the translation factor here for each vertical members. For this side, you have to put this side, and for this vertical member, you have to put this side. Similarly, for the first story, the translation factor, you have to put just midpoint of this vertical member here, and for this side, the right side, so this side you have to put the translation factor. Then you know already that where you will put the fixed and moment of the joint 2 and the joint 5 and joint 4 and joint 3. This is you have to put in the inner rectangular box. Already you know. And the rotation factor also you know. So for U21 you have to put in this box, and for U25 you have to put in this box, and for U23 you have to put in this box. Similarly, the joint 5. So you know what is the rotation factor. So U56 you have to put here, and U52 you have to put here, and U54 you have to put here in this box. Now you are clear. Similarly, joint 4, there is your two rotation factor, U45 and U43. So U45 you have to put here, and U43 you have to put here. Similarly, joint 3. So there is also two rotation factor, U34 and U32. So you have to put in this box and put in this box, 3, 4 and 3. So this way you will put the rotation factor and the translation factor of the vertical member and the fixed moment of the joint. Then the story moment you have to put this side. Then the fixed moment of the end of the member you have to put here. So you know MF34 you got minus 16, and MF43 you got plus 16. You have to put just above this horizontal line, and here also you got MF25. So the end of the horizontal member, the fixed moment that you have to put here, and the MF52 also you got just put above the horizontal line. And for vertical member, the fixed moment is 0. Already we have calculated this. This is 2552, 3443. Then this is the joint moment already we have calculated. So this value you have to put in this tabular form. Rotation factor, translation factor, and fixed moment of joint, and the fixed moment of the end of the members and story moment. Everything you have to put. So after joint 2, then you have to go to joint 5. Similarly, joint 5, what is the sum of the joint moments of 5? You know already what is the sum of the joint moment of 5? What is the sum of the joint moment of 5? This one plus 4.50. And when we will find out at the joint 5, the near and rotation moment, M-5 2, M-5 2, M-5 6, and M-5 4. So here you see this side is your fixed. So you have to assume the far end rotation moment is your 0 here. And this side also you have to assume the far end rotation moment is your 0. But this side you got 3.38 because at the joint 5, how many members meet? 5 2, 5 4, and 5 6. So 5 6 means at 6 this is your fixed. So here the far end rotation moment is 0. Assume here you have to assume the far end rotation moment is 0. But this side you have to take the far end rotation moment is 3.38. And similarly the translation moment, here you assume 0, and here also you have to assume 0. Because at the joint 5, how many vertical members meet? Here 5 4 and 5 6. So the translation moment of 5 6 is your 0, you assume, and the translation moment of 5 4 is also you assume 0. So, this is sum of rotation moment at far end 2 is your 3.38, already I have explained, and sum of rotation moment at far end 4 is your 0, assumed. Sum of rotation moment at far end 6 0 fixed, and sum of translation moment of column 5 4 above is your 0, you have to assume, and sum of translation moment of column 5 6 below the joint, so this is also assumed 0. So these are the moment you have to consider. So this is the formula for M-5 6 to 5 6 5F or F5 plus summation of M-6 5 plus summation of M-5 6. So this is your M-, the near end rotation moment M-5 6 is equal to, you have to take the rotation factor and you have to take all these values 4.5, 3.38, and all other are 0. So here you got minus 0.99. Similarly, M-5 4 is also you got minus 0.99, and M-5 2 you got here minus 1.97, because here the rotation factor is your minus 1/4 for 5 2. So these are the value you got: 5 6 this one, 5 4 this one, and 5 2 this one. So just you put this value in tabular form. So here you got this is your minus 0.99, 5 6 you have to put here, and you got 5 4 minus 0.99 here you put, and you got minus M-5 2 here you have to put. So now you got at the joint 5. So this near end rotation moment minus 1.97, and this is minus 0.99 and minus 0.9. Now you go to the joint 4. 2 is your over, 5 is your over, then you go to the joint 4. So at joint 4, how many members meet? 4 3 and 4 5. So you have to find out the near end rotation moment of this one, and you have to find out the near end rotation moment of this one. So here, how many vertical members meet at joint 4? Only one vertical member. This is the vertical members. So 4 5 vertical members. So what you have to do here? So because you see, when you are considering joint 4, when you find out the M-4 5 or M-4 3, so this is one parent, this is your one parent, and this is your one parent. So this side you have to assume 0, because there is no moment in first cycle. You have to assume 0, but this side you got minus 0.99. This side you got minus 0.9. So the parent, this side you have to take minus 0.99, this side you have to assume 0, and the translation moment you have to assume 0, because you don't know in first cycle what is the translation moment, so you have to assume 0. So similar way, just to find out, this is your joint 4. The sum of joint moment of 4 is your plus 16, you know. Sum of rotation moment at far end 3, you have to assume 0, already I explained. And sum of rotation moment at far end 5 is your minus 0.99 you have to take. And sum of translation moment of column 4 5 you have to assume 0. So this is the, you have to find out M-4 5 and M-4 3. So this is the rotation factor U4 5, and this is the rotation factor U4 3. And you have to put all these value, and you will get what is the near end rotation moment M-4 5 and M-4 3. So M-4 5 is your minus 2.50, and M-4 3 is your minus 5. So then you put M-4 5, M-4 5 is your minus 2.5 you have to put here, and M-4 3 minus 5 you have to put here. Now 2 is your over, 5 is your over, 4 is your over. Then you have to go to joint 3. Similarly at joint 3, how many members meet? 3 4 and 3 2. 3 4 and 3 2. 3 4 member and 3 2 members meet. And these are the rotation vector, and here also you have to find out the near end rotation moment. You have to find out this near end, and this is the near end rotation moment. M-34 is your this one, and M-32 is your this one. You have to find out this. So when you consider the joint 3, you see the far end rotation moment you have to take at joint 3. Already you know this one. 1.69 already know from joint 2. And this side also already you got -5. So the far end rotation moment you have to take -5 and 1.69. Both sides. Only you have to assume the translation moment 3-2. Translation moment of vertical member 3-2 is very equal to 0. Only assume you have to 0 this one, but the rotational moment far end is this one you got already, and also you got already. So you have to take these two rotational moment, and the translation moment you have to assume 0, and you have to take the fixed moment of the joint 3, and you have to take the rotation factor, then you find out for joint 3. Sum of joint moment of 3 is your -16. And sum of rotational moment at far end 2 already I explained 1.69 you have to take. Sum of rotational moment at far end 4 already I explained -5. And sum of translational moment of column 2, 3 you have to assume 0. So this is the value you have to put, and you have to find out M-32 and M-34. M-32 is your 3.22 and M-34 is your 6.44. M-32 is your 3.22 you have to put here, and M-34 is your 6.44 you have to put here. Now the first cycle is your over for rotational moment, and you got the rotational moment, near end rotational moment of the member. You have to find out the translation moment. So now this is your over. So translation moment you have to first go to the story 2. In story 2, so you have to take the story moment here 10.67 in story 2. So here you see this is the formula. So M-23, M-45 is equal to -3/4. This is the 10.67. This is the story moment, and this is the top end rotation moment and bottom end rotation moment. Some of the top end rotation moment and some of the bottom end rotation moment. So this is the formula you have to find out. This is the translation moment for story 2. Then the similar way you will find out the translation moment of story 1. Similarly in story 1, so what is the story moment? 32. And what is the top end rotational moment? Here you got 1.69 and here you got 0.99, but this side the rotational moment is your 0. So you find out and you take the translation factor is your -3/4. So using this one, M-12 is equal to M-56 is equal to -3/4. This is the translation factor, and this is the story moment, and 1.69 here 1.69, and this side you are 0 plus 0, and here also -0.99, and this side also 0. So -24.53. So here you put this -24.53. The translation moment you have to put just in the vertical member inside. For story 1, you got how much? -9.07. Just to put this value 9.07 -9.07, and for story 1 you got -24.53, 24.53. So now that first cycle is over. So in first cycle, what you got? So you got all story moment at each joint 2, 5, 4, 3. Then you got the translation moment for story 2 and story 1. Now the cycle 1 is over. So in the similar way, again you start cycle 2 and start from the joint 2. Again you find out the near end rotational moment. But when you will find out the near end rotational moment, so this side you know the rear rotational moment, so that you have to consider. That you have to consider the far end, and this side you have to take 0. This side you have to consider 1.97, and this side you have to take 3.22. And also you know what is the translation moment also. So this side translation moment you got this one, and this side translation moment you got this one. So you have to consider all these moments, and you have to find out for cycle 2 what is the near end rotation moment. So 5.73, 11.46, and 5.73. Then after getting this one, then you have to go to joint 5. Again here also you have to consider what is the moment you got in second cycle, the far end. This side 0, this side 11.46, and this side what you got in the first cycle, 2.5. And you got here what is the translation moment, you know, and what is the translation moment you know here. So by taking all this, you will find out what is the near end rotation moment, 5.04, 2.52, and this side is 2.52. Similarly, you will find out for 4 and similarly for 3. Then again, you have to find out what is the translation moment for second story. This is minus 15.29, and for first story, this is your minus 30.19. Minus 30. You have to go. You have to start from here and downward. From first translation moment, you go downward. Then after second cycle, then you have to go for third, fourth, fifth, sixth. When you will get the approximate same value, then you have to stop the cycle. And that last reading you have to consider as the rotational moment and the translation moment. So here you see the red mark what I have given here. So these are the final moment. So this you have to consider. This is the translation moment for vertical member 1, 2. This is for vertical member 5, 6 translation moment, and for 2, 3 this is the translation moment, and for 4, 5 this is the translation moment. And these are the rotational moment. Here 0, and this side the rotational moment is this one. This side is this one. This side is this one. Similarly here this side this one. M-5 2 and M-5 6 is your this one, and M-5 4 is your this one. At the joint 4, this is your M-4 5 is this one. M-4 3 is your this one. And at joint 3, M-3 4 is your 10.83, and M-3 2 is your minus 18.47. And this is the translation moment you have to consider. So after knowing this rotation moment and translation moment of the end cycle, then you can find out what is the final moment. So this is the final moment. Here you see the formula you have to use here. This is the formula you have to use. M12 is equal to M-12, 2 M-12, M-21 plus M-12. But this is you have to not consider for the horizontal member. This moment, the translation moment, you have to not consider for horizontal member. The vertical member, you have to use all this fixed moment, end of the member, twice near end rotation moment, once far end rotation moment, and the translation moment of the vertical member. Here you see. So here you have to find out M12. So M12, you know here what is the rotation moment? 0, and this side the rotation moment is 6.22, and the translation moment is minus 32. So 0 plus 6.22 minus 32. 0 plus 6.22 minus 32. So this is the final moment. Similarly, M21. So M21 here you see this is the rotation moment, and this is the here the piston moment 0 plus 2 into 6.22 plus 0 minus 32 minus 32. 6.22 0 minus 32. This is the final moment. Similarly, find out the M25. So M25, you know what is the piston moment at the end of the member? Here this one, and this is the near end rotation moment 2 into 12.44, and this is the far end rotation moment plus 8.91. But here you have to not consider this translation moment. This is not required. Minus 13.50 plus 2 into 12.44 plus 8.91. So this is equal to M25. Then find out M52. M52. So here this is the piston moment, and this is the near end rotation moment 4.5 plus 2 into 8.91 plus 12.44. 2 into 8.91 plus 12.4. This is equal to 34.76. Similarly, find out M52. This is vertical member. So here there is no piston moment, and the near end rotation moment is 4.45, and the far end rotation moment is 0. And the translation moment you have to consider for the vertical members. So here 0 plus 2 into 4.45 plus 0 minus 32. 4.45 twice 0 minus 32. So this is minus 23.10. Similarly here also you find out. So this is the near end rotation moment 0. And the piston moment, this is your 0 near end rotation moment. Fixed moment here also 0. And the far end rotation moment is 4.45. And the translation moment is minus 32. 0 plus 0 plus 4.5 minus 32. 4.5 minus 32. This is minus 27.05. Similarly, find out here M54. M54. So here when you will find out M54, so here the piston moment is 0, and the near end rotational moment is your 4.45, and far end is your minus 2.13, and the translational moment is your minus 18.47. So M54 is your equal to 2 into 4.45 minus 2.13 minus 18.47. 2 into 4.45 minus 2.13 minus 18.47. So this is a minus 11.70. Similarly, find out M45. So this is near end, and this is you have to consider far end. 0 plus 2 into minus 2.13 plus 4.45 minus 18.47. Minus 2.13 twice, 4.45 minus 18.47. So this is the final moment. Similarly, here also you have to find out the final moment is your this is minus 4.25 minus 4.25 plus 10.83. Similarly, here also this is the final moment. So after these are the final moment value, and here also this is the final moment. So after getting the final moment, then you have to give the direction of the moment. You have to give, because this is your negative you got here, means this is your anti-clockwise. This is the direction. This is you got positive. This is anti-clockwise. This is the direction. Anti-clockwise. This is the direction. And here you got this is your positive clockwise. This is you got negative anti-clockwise. This is direction. This is the direction. This is. Similarly, you have to put the direction of the moment. Afterwards, then you can draw the bending moment diagram. Now we'll stop here. So once again, we'll discuss in next class this the direction and the final bending moment diagram.